Hey everyone, Mr. Skelton here, back at it. This is Unit 7, Lesson 4. Almost switched it around. Today we're going to start our discussion on the unit circle, and I know this looks intimidating to you when you're looking at it, but this is what you are going to do, or this is going to be your assignment for Unit 4. Your assignment is going to be, you're going to get one of these that are completely blank. This is the unit circle completely filled in. Just I'll point out a couple things to you. You'll see in orange highlighter, these are the degrees, 30, 45, 60, 90, and you may start to see some patterns, and we'll talk about it. In pink, right next to 30, you see radian measures, and we haven't even talked about what a radian is, but we'll talk about that here in a little bit. And each degree has a radian that is of equal amount. They're just two different measurement forms. The next thing you'll notice probably are some points. You'll see 1, 0, and you see some points around the unit circle. I wish this picture had an actual point here. You can put little dots in here. So this dot right here is square root of 3 over 2 comma 1/2, and you'll see points all the way around here. So that's another thing that you'll notice. And really, that's all we have on the unit circle. So again, your job, and if you just turn the page, you'll see there's a blank one right here. Your job will be to completely fill in the unit circle. So that's what I'm going to be asking you to do here in a little bit. So next, let's talk about why the unit circle. What's the point? What are we doing? Why is this even something that we're attempting to do? Well, I'm going to be honest with you. This is something that you're going to focus on a lot when you get to trig, when you get to your trig and pre-calc class next year. What's funny is, I find it's ironic, is we call it the unit circle, and it's very common and you'll see it a lot, but really it's not about the circle at all. Really what we're going to focus on is right triangle trig, and that's the most important thing to take away from this. You are going to be creating right triangles and using knowledge that you already know about 30, 60, 90, and 45, 45, 90 triangles. Notice that if you look at these degree angles, they're all in increments of either by 30 degrees, 45 degrees, or 60. So that 30, 60, 90 triangle work that we did, those special right triangles, that is all going to come into play, and it's going to help you fill out these points around the outside. So yes, it's called the unit circle, but really the focus is on creating right triangles, and I'm going to show you how to do that. So the most important thing about the unit circle is that you understand that the radius is 1 unit. The reason we call it a unit circle, I like to call it the 1 unit circle, is because this is the center, and from here out is 1 unit. This is your x-axis, this is your y-axis, so it's still on the coordinate plane. You can see these are coordinates here, and it's 1 unit. And so this distance all the way around, all of these lines have a radius of 1, and that's why we call it the unit circle, or the 1 unit circle, because the radius is always 1. That's important when we start to get into our right triangle trig and drawing these out. Okay? So that's the most important thing there. Now, let's turn the page. Well, let's not turn the page. Let's do this. What I'm going to do is have you draw right underneath here. I'm going to have you just kind of, as best you can, draw an XY coordinate plane. Okay? And we're just going to put a circle around it. This is kind of mimicking a unit circle. All right? And I'm going to draw just a line, a radius. Okay, that's a radius. And this is the unit circle, so that's going to have a distance of 1. All right? I'm going to put this point here. And what I'm showing you here is how that the unit circle is all about right triangles, creating right triangles and figuring out dimensions of that right triangle. What we're going to do is we're going to always draw down an altitude, and that's going to create our 90-degree angle. An altitude always creates a right angle. This point right here is going to be these points that you see around the outside or the circumference of your unit circle. Now, let's think about this for a second. We know the distance from right to left is always your x, and the distance up and down is always your y. So if this is theta, okay, that angle theta, we know that this point is going to be x comma y. Now the other way to think about this, and we've already talked about this, is if I go opposite over hypotenuse, that is your sine, right? Sine of theta equals opposite y over hypotenuse 1. So what does that mean? That means sine of theta equals 1, or excuse me, equals y, which means y is sine theta and x is cos theta, because your x value would be adjacent over hypotenuse. So yeah, we think of it as xy, but it's also important to think of it as cos theta sine theta, okay? So that's important to know. So let's go to the next page, and what I wanted to show you here, I'll kind of zoom in a little bit for you, is how we create all of these points, okay? So how we were getting all of these points around the outside, so I'll kind of slide this in. I got a couple here so I can kind of bounce back and forth, but like for example, showing you how we are getting 1/2 for a 60-degree angle, 1/2 comma 3/2. Well, it's all about right triangle trig, right? So here's your 60-degree angle, here's your 30. Remember, this hypotenuse is 1 because it's a radius, it's a unit circle, 1 unit, so that's 1. And remember our rules about 30, 60, 90s, right? Remember we said for 30, 60, 90s that the hypotenuse is always 2 times the short leg, and your long leg is the square root of 3 times your short. Those rules are coming back into play. So if your hypotenuse is 1, you know that your short leg, if you put a 1 in here, 1, and divided by 2, your short leg is 1/2. So that means our x coordinate would be 1/2, right? Because this distance is x. And then we know that our long leg is the square root of 3 times our short, which would just be 1/2 times square root of 3/2, which would be square root of 3/2. And that's why this is our y distance, or our vertical distance. So this point right here would be 1/2 comma square root of 3/2 when you have a 60-degree angle, okay? And so that's how we're going to find those points, all right? Likewise over here for a 45, 45, 90, and we'll kind of go back and forth, but again, if this is 45 degrees, so I'm sliding this over, this 45 really goes here, so this 45-degree angle, we would come up, we would draw this triangle straight down, and that's how we're going to get this triangle in here in our unit circle. If our hypotenuse is 1, remember that we have the hypotenuse for 45, 45, 90 is the square root of 2 times a leg, right? Leg times square root of 2. So when we have, when we're trying to find the leg distance, when we know this is 1, we would have something like this. 1 equals the square root of 2 times a leg. Well, how would you solve for a leg? You divide by radical 2, right? And a leg would equal 1 over radical 2. Well, we have to rationalize the denominator. So we would go radical 2 over radical 2, which would be radical 2 over 2, and that's a leg, which we can see right here and right here. That's why when you go, so this point right here, B, remember, this is your x distance, so that would be radical 2 over 2, oops, radical 2 over just 2, comma, your y distance is radical 2 over 2. And that's why when you look back here at the original, for a 45-degree angle, look at your point, radical 2 over 2, radical 2 over 2, based on the triangle that we created, okay? So that's good to know. This represents, so here's another way, like a good quiz question, I can say, what is the sine of 45 degrees? Well, you know 45 degrees, we know this is always cos, and then this is sine, so that would be radical 2 over 2. It's good to memorize. I kind of put the common ones in here that you're going to see throughout the unit circle, okay? Next, let's talk about degrees. So when you look at this, a lot of the times one of the first questions I get is, well, how do you know what degrees go in there? You know, why don't you go like 22 and 15 and whatever? Remember the point of the unit circle. The unit circle is not about the circle. The unit circle is about right triangles and finding distances and, you know, indirect measurements. Like, this is so applicable because this is a unit of 1, but anywhere in life you use triangles, right triangles, all the time to find heights. Like if you wanted to find, you probably remember those problems like, you know, a flagpole is so high and you can measure the angle of elevation. Obviously you can't crawl up the flagpole and try to measure it. You have to use indirect measurement. And so this allows us to use indirect measurement down the road when we want to scale this to a much bigger. Like if we had 10, well then everything would be multiples of 10 all the way around, right? So the ratios would stay these ratios stay the same. I know I'm kind of getting off track a little bit, but I want to drive home that these are all triangles. And so the reason we use 30, 45, 60, and then obviously you can see if I go 30, add 30 is 60, add 30 is 90, add 30 is 120, add 30 is 150, add 30 is 80. These are all just the same 30, 60, 90 triangles all the way around. Like this isn't a 210 right triangle. This is a 30-degree triangle because if that's 180 and this is 210, if you subtract those, that's 30. So this triangle right here is the same as this triangle right here. So really the focus for you is going to be on this. If you can handle these three, or this quadrant, quadrant 1, you'll notice that these are just reflected over the other side, right? Look at here and here. Square root of 3 over 2, comma 1/2. If you take this triangle and just reflect it over, it's in the quadrant 2, right? This is quadrant 2, this is quadrant 1, this is 3. So you have to follow your rules of the quadrants. It's just reflected over. Radical 2 over 2, radical 2 over 2, 45. It's the same thing over here, it's just negative. This is the 60-degree one that we showed you. If you reflect it over the y-axis, it's the same numbers in the same order, it's just reflected. And then you can reflect over the y-axis. So notice this is 30 degrees here, this is 30 degrees here, it reflects over. These two are the same. It's just opposite positive and negatives. The middle ones are reflected, this one's reflected, and then these get reflected here and here. Look at, they're the same. These get reflected here and here, they're the same, here and here. So it's a bunch of just 30, 60, 90, and 45, 45, 90 triangles replicated around, okay? All right, so let's keep moving here. And let's start filling this out on our own. And I'm going to try to give you some strategies as to how to do this. So let's go ahead and start with the points first, because I think that's the easiest thing to do. So obviously this straight line right here is going to be 1, 0, right? Because it's 1 unit, so that's 1, 0. This would be 0, 1. Okay, this would be negative 1 and 0, so 1 unit to the left. Again, this is your y-axis, this is your x-axis, and then this would be 0, negative 1. That's where I normally start. Okay. Next, I would do degrees. Now, it's important to understand that degrees, we go counterclockwise. Okay. So maybe on your notes, I have fill in the unit circle. Let me move this up just a touch. So I would say when you go degrees, it's counterclockwise. Okay? So we basically start here at 0 degrees, and then this would be 30, this would be our 45, and then 60, and then this would be 90. A lot of people will go 0, 90, and they know this is going to be, this is going to be 180, right? So 0, 90, 180. Another 90 would be 270, and then you're back to 360, right? Or 0 degrees, but you would get to 360, okay? You can go multiple times around this. So you can go 360, and I could say, okay, what about 390? Well, if this is 360 around this way, 390 would be adding another 30, so 390 degrees would be actually right here. You can also go negative distance. You can go negative 30 degrees. That would be here. So when you go negative degrees, you're going around the opposite way, or clockwise, okay? All right, so if we're going by degrees, a lot of students will go 0, 30, they'll go by 30 degrees. So they just skip the middle one because the middle is the 45. So they go 0, go in increments of 30, 30, 60, 90. This would be 120. Skip the 45, so add 30. This would be 150. Notice I'm going in increments of 30, so there's 180. Another 30 would be 210. Skip the middle one because that's the 45. This would be 240. And then that would add 30 to 270. The next one would be 300. Skip the 45. This would be 330. Okay, so that's how I do the degrees, and then you got to go by 45s to hit those middle ones. So 45, add 45 to 45, you get 90. Add 45 to 90, that's 135. Add 45 to 135, you get 180. 180 plus 45 would give you 225. Add 45 to that, you get 270. Add 45 to 270, and you get 315. Okay, and now we have all of our degrees taken care of. These never change. Those are going to be your degrees. Okay. Now, if you want to, the next thing I would probably do is start to fill in your sides. Now, if you need to, draw the right triangle. So what I mean by that is this. Let me grab my pencil here so I can maybe erase. When you first start to learn this, a lot of you are probably going to do this. You're going to draw this in. I hope you can see that. Okay. This would be your 90, right? This 30, I know it's written here, but it really means this is 30 degrees, this is 45 degrees, this is your 60 degrees, right? And so you can see my 30-degree triangle here. This is 1. That's the unit 1. So you need to fill out, we're filling out these points. Well, if that's 1, okay, we already did this right here, except we did it with not a 60. But if we did it with a 60, this is a 30. So let's just do it real quick. If this is 1, and this is your short leg, okay, so remember your equations. Your hypotenuse is 2 times your short. So if my hypotenuse is 1, and that's 2 times my short leg, that means I'm going to have 1/2 right here, because I'm going to divide by 2, right? So that's 1/2. Well, what distance is that? That is my y, because it's my vertical distance. So that means this is radical 3 over 2, because that's your long leg. Okay? So that would be radical 3 over 2. 45, 45, 90s are the ones students usually get the most very quickly, because again, we already did this on the other sheet, right? We did this right here. We know that the horizontal distance and the vertical distance is radical 2 over 2. So those 45, 45, 90s are kind of nice. All right? And then what's cool about the 30 and 60 is these are just flip-flopped, because if you think about the 30-60, it's just a reverse of your short leg and long leg. So this is just going to be 1/2, and then this is going to be radical 3 over 2, which is it's just the opposite of the 30. And again, we did that here. Okay, you can see 1/2 radical 3 over 2 for your 60-degree angle here. Now, where you go from here is kind of what best suits you in terms of the points. Like, I like to just reciprocate over the axis. I always do my 45, so I got to be careful because this is a negative radical 2 over 2 because I'm going to the left, so which is negative. Remember, you're dealing with quadrants and things like that. And then, but I'm still up radical 2 over 2, so it'd be left radical 2 over 2, up is positive, so that's why that's there. In quadrant 3, you're going to go to the left. I'm going to do my 45s. I like to do my 45s first. So to the left, so that'd be negative radical 2 over 2, positive radical 2 over 2. This would be positive, my 315. Remember, the middle line is always the 45, quote unquote, the 45-degree angles. So this would be to the right, radical 2 over 2, and then down, so that'd be a negative radical 2 over 2. Okay? And then you can do this however you want. If you want to focus on this next, this radical 3 over 2 comma 1/2, and reciprocate that underneath, so that would just be the same thing. That'd be radical 3 over 2, but it's going to be negative 1/2 because we went to the right radical 3 over 2 and then down 1/2. And then I would flip over, so that's going to be negative radical 3 over 2 and 1/2. And then I would flip down. So I kind of go my 30s, I flip over, flip down, all with my 30s. So that would be negative radical 3 over 2 and negative 1/2. I forgot to make this a negative. I apologize. That's to the left and down. That should have both been negative there. Okay. And then I go to my 60s. So I always flip over the x-axis or y-axis first. It doesn't matter. This would be, if you just reflected this over the y-axis. So this is going to be negative 1/2 because you're going to the left, and then up radical 3 over 2. It's the same as this. And then we can reflect down. So that would be 1/2 to the right, and then negative radical 3 over 2. And then we would take this one and flip it down. So this would be negative 1/2 and negative radical 3 over 2. So there's all my points. Because again, they're just replicated triangles. This is a 30-degree triangle right here that we created, but so is this. Even though this is 330 degrees, it's still a 30-degree triangle, because from here to here is still 30 degrees, so it's just replicated. All right? Okay, now the only thing we're missing from our unit circle is our pink radian measures. What is a radian? A radian is just another unit of measure. So a radian is short for a radius. And so what I want to do is show you something very neat here. This is where you get a little happy mathy. I'll zoom in just a touch. So a radian is, for this example, this little shoelace I have here, that is a radius. So that is 1 radian. Radians are always measured in terms of pi. Okay? So watch how this works. Now you know what is pi. Pi is 3.1415, right? The number goes on forever. And here's why this is. A lot of students, why is pi this? Let me show you. This is 1 radian. Well, if I take this radian, or this radius, I'm going to go around the half circle here. Watch what happens. And I'm just going to rough this. So this is 1 radian. So I'm going to put it here and wrap this around as best I can to kind of show you an example. So there's 1 radian. I'm going to put my finger right here, start it. There's the 2nd radian. Okay? I'm going to keep my left finger here, about close to 120. There's my 3rd radian. Now look, once I have 3, what do I have left? I just have a little bit more, right? So how many radians did I count? 1, 2, 3 with a little left. That's why pi is 3.14. That's pi radians is 3.14 because it's 3.14 basically radians, which is pi, which is kind of neat. Okay? Now, a lot of students, when they're filling out the unit circle, will do something like this. They'll start at, this is going to be actually 0, okay? And then we're going to have pi over here, all right? You basically have 0 to start with. You have 0 pi's, right? Just like you have 0 degrees. You know that pi is 180, okay? And I'm going to show you how that works in a little bit. So if you go here to pi, what does this have to be? This would be half of pi, right? So you got half of pi, another half would be pi, then you would have 3 halves pi, because you have, we're going by halves, half a pi, half a pi, half a pi, and then this is also, I'm going to put a comma, this is 2 pi, because that's 360, right? So you have 180 as pi, 2 pi would be 360, okay? Now, we got to figure out how to get these fractions of pi. These are our radian measures. This can get a little tricky, but I'm going to show you how I do it, and hopefully it makes sense to you. So I'm going to teach you a conversion, and this is important. It's going to help you out along the way. A basic conversion to degrees to radians. It basically works like this. You're going to set up a simple proportion. Pi radians is 180 degrees. So that's a ratio where those are the same. And so, like for example, if I want to convert 30 degrees into radians, you would go pi over 180, because those are the same. This is radians, this is degrees. We want to know radians, so I'll call it x, because I want to know what 30 degrees is, but I know that's 30. So it's pi over 180, and this is always going to be constant. This is what you're always going to use right here. And then on the right side is what you want to figure out. So I want to figure out radians over degrees, and I cross multiply. So what do you get? You get 30 pi equals 180 x. What are you solving for? You're solving for x, right? So if I divide both sides by 180, you get basically x equaling, divide that out, your zeros cross out, 3 over 18 is basically 1/6, so you have 1/6 pi. So pi sixths is your radian measure. It's a sixth of pi. That's the other way you can think about it, right? If you just take 180 divided by 30, and 180 is pi, it's a sixth of pi, because from here all the way around is pi. 30 degrees would be a sixth of that. And so that's one way you can do it. Another way students will do it next is, now they'll just go like this. This is what I do. I go pi over 6 is 1/6. Another 30 degree would be what? It would be 2/6. It'd be 2/6 pi. I'll do it in pencil. This would be 2/6 pi. I'm going to draw it light. Now what is 2/6 pi reduced to? That reduces to 1/3. We'll come back and do that. So if this is 1/6, another 30 degrees would be 2/6. 3/6 pi, right? This is 3 over 6 pi, which we already know is pi over 2. I'm going by 30 degrees. So this would be 3/6. This would be 4/6. So this would be 4/6 pi. We'll reduce that later. This would be 5/6 pi. This would be 6/6 pi, which makes sense, right? And then we go another 30 degrees. That would be 7/6 pi. This would be 8/6 pi. This would be 9/6 pi, which we know, right, because 9/6 reduces. 9/6. This would be 10/6 pi. This would be 11/6 pi. 12/6 pi. What's 12 over 6? 2. So that's how I do my radians. You don't have to do it that way. You can think of it, but I go 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. And I'm going by 30 degrees because 30, 60, 90, 120, 150, I'm going in increments of 30. And then I do the same exact thing with the 45. What is 45 degrees in terms of radians? Well, it's 180 divided by 45, which is a fourth. So it's 1/4 pi, or pi over 4. And then what I do is, to fill in these middle ones, I go by fourths. So if this is 1/4, go another 45 degrees. That's 90. So that's 2/4, which should make sense. This would be 3/4. This would be 4/4, which we know. This would be 5/4 pi. This would be 6/4 pi. This would be 7/4 pi. This would be 8/4 pi. Okay? Now, the one thing that I did not do is I did not reduce my fractions where I could, and you want to do that on your unit circle. What I mean by that is we have pi over 6 is reduced, 1/4 is reduced, 2/6 reduces down to 1/3. But I put this here because I want you to understand 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, all the way around. Just like 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. But you want to go back and go, okay, 2 over 6 is 1/3, so that's pi over 3, or 1/3 pi. 4 over 6 would reduce to 2/3, so that's 2/3 pi. All these are reduced, those are reduced. 8/6, right, would be 4/3 pi. We already know that one. 10/6 reduces down to 5/3. 11/6 is all reduced, and there's your unit circle, okay? So I'm going to stop there because really we're just going to practice this over and over again. Hopefully you picked up a couple things. I don't expect you to have this down cold, but hopefully you picked up a few things there that'll help you when we get to class, and we're just going to practice these over and over and over again, all right? All right, I'll talk to you in class.